Hi everyone. Today we have a situation from the topic Motional EMF from electromagnetic induction. In the scenario today, we have two rings of radius r and 2r moving with a velocity v and 2v opposite to each other, and we have a conducting surface and a magnetic field which is pointing into the plane, and we have to find the potential difference between the points P and Q, where P and Q are the instantaneously highest points of the rings, right? So we know that we'll be applying the motional EMF concept here, and again we have two motions here, the rotational and the translational motion. So as a fact, we'll be considering the translational motion for the two rings here, because the rotational motion will not result in a flux change, right? So we'll be talking about the translational motion here. Now for any translational motion for the rings moving with a velocity, let us say any velocity v, we know that the EMF or the delta v, the potential difference, is B times VL, right? Where L is the length we'll be talking about and v is the velocity for any of the two rings. Let us draw a DC diagram, a diagram for DC circuit, since the surface is conducting in itself. So we'll be talking about the EMF. Now we'll be considering the direction of EMF from the right hand thumb rule. V vector cross B vector dot with L vector, and V cross B is just the direction of the motional EMF. So the direction for the first motional EMF for the first ring will be downwards, and we'll have a conducting wire because the surface is conducting again, and we'll have this EMF E2 as the second EMF. We have the point P and the point Q, so we have VP and VQ, right? And we are given with EMF E1 and E2. Now the potential difference between the 2 points P and Q will be E1 plus E2, right? And E1 in our sense will be the magnetic field times the velocity for the ring 1. Now the velocity for the ring 1 is 2v, so we have 2v, and the length will be 2r. So the length for the first ring will be 2r and the length for the second one will be 4r, vertical distance, right? So we have this times the length, which is 2r, and now again for E2 we have b times the velocity is v and the length is 4r. So for both the scenarios we have 4 times bvr as the induced motional EMF, right? So we have E1 and E2. Now since we were to find the potential difference between P and Q, we have E1 plus E2. So that brings us to the answer, which is 8 bvr, right? So this will be the potential difference between the highest points, which is at any instant when the two rings are traveling with the velocity v and 2v for the given radii. And for this very scenario we have a magnetic field perpendicular to the plane as well, and a conducting surface, we can't forget this. So that brings us to the end of the question, and we have the answer. So yeah, thank you again for your time.